Okay, Assalamualaikum and very good morning to all. Okay, today we will continue our next lecture, okay, on the mechatronics. Okay, you have learned before this on the introduction of mechatronic system and also hydraulic and pneumatic actuator system. And basically, this is the last part of my lecture, okay, which is they have three content, okay, or three parts. The first one, second and third, okay. So on this electrical actuator system. Okay, so for the learning outcome, okay, this is covered on the CO number 6, okay, course outcome number 6. And at the end of the topics, you as a student should be able to first to explain the operational characteristic of electrical actuation system. Second one, able to explain the principle of DC, okay, direct current and step motor. The third one, to able to determine the torque generated by a motor, and finally, able to explain how the speed of a motor can be controlled. Okay. Okay, so this is for the outline for today. Okay, which is the first one on the electrical system. Okay. The second one is on the mechanical switch, which is content of a relay. And the third one is on a solid state device, okay, which is content of diodes, transistor, thyristor, and triacs, bipolar transistor, and finally MOSFETs, which is on metal oxide field effect transistor. Okay, let's go to the first one, which is on the electrical system. Okay, so basically, in an electrical system, we use the actuator. Okay, the electrical actuator to control, which includes you along the lecture. You will go through these three terms. Which the first one is a switching device, which include a mechanical switch, for example, relay, and also the solid state switch, which is include the diodes. Okay, thyristor, and or transistor. Okay, so this is the application is as a switch, which is to on or off a electrical device lah basically. And the one is on the solenoid type device, which is a type of device that used to actuate a valve of the pneumatic and hydraulic system. For example, you have done and learned before this on how to control the flow of the air and oil to this hydraulic and pneumatic system, okay, using the solenoids. For the electrical device also, we have to have a solenoids, okay. So the drive system, okay, such as the DC motor, AC motor, and also the stepper motor. Okay, the first one is on the mechanical switch. Okay, what is a mechanical switch for? In general, is a elements which is often used as a sensor. Okay, to give inputs to the system. Okay, for example, electrical relay. Okay, so relay are actually a electrical operated switch lah. Okay, is a in a electrical component is a operated switch. Okay, and in which can change a current in a one electrical circuit, okay, to switch current on or off in another circuit. Okay, is a controlling switch lah for basically. Okay, so this is some of the figures on the relay and open relay. Okay, and also the closed one. Okay, so how it's work? Okay, so basically when you give supply current through the solenoid of the relay, okay, the coil here, okay, we have basically it's a solenoid. So it will generate a magnetic field, okay, and then it will attract this armature and move push the rods, okay. So basically when the armature move due to magnetic fields, it creates this normally close and normally open switch lah, okay. So when it move, so this rod can break and the normally open will close here, and goes to the normally close, it will push the rods and it will uh, opens, okay. So that's the contact that can be made using a relay basically. Okay. So relay are often used in control system lah, in the conjunction of a transistor. So basically we need a transistor here. Okay, for example, the ZTX300s. Why we need this is due to small current from the controller. So basically when you use any of the controller, it cannot generate a very high voltage or currents, okay, due to some limitation, and we need some of this such as amplifier or like a transistor so that it can generate or amplify the currents to a certain level so that it can move the system lah, such as for the electrical heater, motor, automotive starter, and so on. Okay. So diode is a protective device. Okay, we also need it, which mounted as a series here. Okay, sorry, as a parallel here, to avoid a back voltage. Okay, when sometime the energizing circuit switch is off. Okay, so also in the case of trying to change the voltage from high to low, so they need such as a protective device lah, so a diode, so that there's no back voltage that can make the other components broken. Okay, so this is a real the circuits. Okay, the schematic one and the electrical circuit symbols. Okay, this is the diodes, protective diodes. This is the relay here. Okay, and also this is the transistor. Okay, so how it works, okay, two relays might be used to control operation of the pneumatic valve, for example, which in turns control the movement of the piston lah. Okay, this is you have three cylinders of A, B, and C here. When we close the circuit, so the voltage is go through this solenoid. Okay, and it move the A plus here. Okay, the as what you learned before in the hydrodynamic circuits. So it will extend the piston. Okay, let's go through the solenoids here. Okay, this move here. Okay, on the directions, and it go to this parts and it breaks this piston. Okay, so same goes to the voltage here. This go to the P plus here. Okay, and voltage go through the piston to move to extend. Okay, and finally when it's in contact with this B plus, okay, so we will go to this C plus, also will be reacts. Okay, and it's applied to the C plus to extend. Okay, as this circuit is activated, okay, it move back here. Okay, so basically we have complete this A plus B plus simultaneously, and it's followed by C plus lah. Okay, A plus and B plus most simultaneously because it's generated at the same time, this at this two voltage. And after C is moved and it's a interact of this circuit line, and we go back to the A minus and B minus here. So it will retract back both, and finally after A minus and B minus have been retract, so that finally it will contact back to the C minus here to complete the C minus movement of the uh, hydraulics or this electrical piston. Okay, so this is the same concept on the how it can be used to move this uh, system lah. Okay, okay, so for the solid state device, okay, solid state device can be used to electronically switch a circuit lah. Okay, so the relay is a mechanical switch, and for the this one is on the electrical switch. Okay, so we have a diodes. Okay, thyristors and triacs. Okay, bipolar transistor, and finally a power MOSFETs. Okay, there's four solid state device that can be used. Okay, the first one is diodes. Okay, this is the characteristic of the diodes here. Okay, so this is basically the size lah that we have. It's about 3 cms in size. Okay, it's a very small one. Okay, And we have this graph. Okay, the x-axis is voltage generate and voltage supply, and the y is the current that has been generated. So is this diode only pass current when the forward bias, okay, only react in the positive one, the positive forward bias. Okay, when the reverse bias is there's no voltage or current that's been supplied. Okay, it will break down automatically. Okay, the breakdown when the reverse bias at the high voltage lah. Okay, so that's the function of diodes too, as a protective device to avoid a negative voltage. Okay, so in the case of we supply alternate voltage here, okay, sine wave voltage, it can only switch on the positive half cycle lah. Okay, so as it is cannot react on the reverse bias, so it can only generate at the positive half cycle. Okay. Okay, so the next one is thyristors and triacs. Okay, what is the difference between this thyristor and triac compared to diodes? Okay, the thyristor is a silicon control rectifier. Okay, this is regarded as a diode which has a gate controlling. Okay, that's the difference. We have a gate controlling the condition under which diode can be switched on. Okay, for the thyristor, this is the symbol lah. We have a gate here, controlling gate. This is the the pictures lah. Okay, we have A as an anode, C as a cathode, and G as a gate. Okay, so it's not reacts in the negative or a reverse ones. Okay, it's only react as a positive, as a forward one lah. Okay, so similar to these diodes, but this thyristor have a forward back breakdown lah. This one has no breakdowns, level control, but this one have a breakdown control. So when you supply a voltage here, for example, of a high voltage of 300 volts, it can break down the voltage to up to 1 to 2 voltage only. Okay, so that's the function of thyristor lah. Is have a gate controller. But in case you mounting the resistor in series of this gate, okay, or this thyristor, it will reduce the voltage. Okay, for example, you supply a 300 volts. Okay, when the forward breakdown occur, it will down the voltage or 1 to 2 voltage, and you have about 298 volts across to this 20 ohm of resistor. Hence, by using a V equal to IR equations as a basic equation, you can get of this amplification lah of the current, which 14.9. Okay. Okay, the higher the current supply, the lower the breakdown voltage. So this is the principle of the thyristor lah. I mean that's the higher the currents, the lower the breakdowns voltage that will be given lah. Okay. So what is triacs? Okay, this is similar to the thyristor, but we have equivalent of a pair of thyristor connected in reverse parallel on the same chip, so that it can be turned on both forward and reverse directions. Okay, it is a simple basically. Okay, inexpensive and used to control the AC power lah. So compared to this graph, you have only forward breakdowns, but as you use triacs, it can react in both forward and reverse breakdowns. Okay, so the symbol also is quite different here. It says two of the like diodes symbols. Okay. Okay, this is effect that can be occur when the sines wave of the alternating voltage is applied across the thyristor and triacs. Okay, so for the thyristor, you can see it's only can cut the voltage, okay, down to the certain level, but only in a positive or the forward directions. But for the triacs, okay, you can see it can react in both forward or reverse direction, or plus and minus directions. Okay, so Okay, example of how a thyristor could be used to control a steady of a DC voltage. This is example. Okay, when you have a voltage, okay, resistor and also the thyristor or triacs. Okay, so this is used as a switch on off device. Okay, where it can supply a voltage can be chopped. Okay, it can be chopped like this at the green line, and intermittent voltage is produced. Okay, so the V average also is differs based on the what amount of the voltage that been supplied, the type of sine wave. Okay, this have this amount of voltage in the positive directions, so we have a different of T1 and T2 here using these equations. So if the amount of voltage wave is different like this, so basically you will get a different average voltage lah, okay, for both of thyristor cases. Okay, so this is a real some of a real example on the how you can control the currents for the electric heaters, electric motor or lamp differs. So we take example of the lamp dimmers. Sorry, I think most of you has experience in your house. Maybe there's a lamp dimmers lah. How you can have a bright or more dim light in your rooms. Okay, let's say we have example of alternate voltage that we supply. Okay, so in the voltage, we have basically two, this R1 and R2 as the current limiting resistor and also the potentiometer. So both this is they can set for at what levels the thyristor will be triggered. Okay, so we have a thyristor mounted in series with the loads here. Okay, and also basically diodes as a protective device mounted which together in the circuits. Okay, as we control this potentiometer, okay, we move the tube, the what we have in that our lamp, like a cylindrical one. When we tune it, we have not tune it. Is at the 0 degree position. We can supply a full of the voltage, which means that it's a fully bright ones. But if we turn it to 90 degree, so it give a half of the output currents, so that it can dim a little bit. So this is how the thyristor play a role to have a break down at the positive, okay, uh, positive half wave here. Okay, so the lamp can be dimmed, which more protective support from the diodes also. Okay, so in order to prevent sudden change in source voltage as you are playing with voltage, you turn the cylindrical switch fast and slow. This may have a some of the effects to the voltage that may affect to the circuits also. So the rate of which voltage change with time. So it can be controlled by a snubber circuits. We call it snubber circuits. It is a resistors in series here. Okay, with the thyristor here. Okay, resistor that mounted in series, which also with capacitor. Okay, resistor in series with capacitor here. Okay, this is resistor, this is capacitor, which mounted parallel to the thyristor lah. Okay, so this snubber is basically is a simple kind of shock absorber lah. If you drive a car, this a protective of the shock absorber. You go through the bumper. So the same concept in the electrical circuit, which intend to suppress the voltage spikes. Okay, sometimes when there are some problem electrical, so in order to protect on the voltage spike that can block your lamp, for example, the so that we need this called the snubber. Okay. Okay, maybe you can try this. Let's say write down the keywords to example the difference between diode and thyristor. Okay, maybe you can do because we have some characteristic of the graph and also some terms that can mix what is the difference between diodes and thyristor. Okay. Okay, moving next is on the bipolar transistor. Okay, it's come in two form, which is PNP and NPN and PNP. Okay, so transistor are made are manufactured in different shapes, but they have three leads. Okay, so this is the example of the transistor. Okay, the base one, okay, the middle one is the lead responsible for activating the transistor. Okay, the collector which is on the positive side, okay, and also the emitter which is on the negative lead. Okay, so we have NPM. Okay, basically the main current is applied toward the collector, and is going out to the emitter lah. Okay, so the control voltage is at the base. Okay, say different to the PNP, you have the main current supplied to the emitter and going out to the collector, and the current controls is at the base. So this is basically the symbol we represent as this lah, this NPN. The arrow is going out here, PNP is going down here, going inside here. But this is just to give a different explanation on how the collector and emitter respond lah, from collector to emitter and from the emitter to collector. But in the general, we represent it as this one, the different on the arrow. Okay. Okay, this is some of a more detailed explanation that you can go through this Wikipedia website on general what is NPN and PNP transistor. Okay, as a bipolar transistor. Okay, you can go through a little bit detail on the other source also. Okay, so this is on the characteristic of common emitter circuit. Okay, basically you have a supply voltage here at the base. Okay, and it is relate to the IC. Yeah. Okay. Okay. This is the base and this is the collector. Okay. Okay, the base one. Okay, and the collector. Okay. So as the base one. Okay. As you have this graph. Okay. It's a potential difference between the collector and emitter lah. Okay, we as the increase the value of base currents, so the collector current also will be increased. If you can see the graph also, but the potential difference between the collector and emitter is basically reduced in time because of this resistor. Okay, so the mounted resistor basically will reduce the potential difference between the collector and emitter lah, as the even though the base current is increased and the collector current is increased, but the difference between the collector and emitter here is reduced by the RC resistor. Okay. Okay. So as you go through this, uh, the SVCE is reduced. Okay, it's going to this saturation limitation lah. Okay, so this one is can be explained more detail. Okay, okay, on how V out here. Okay, and a V in relationship. Okay, so as a V out, VCC is a part of the V out. Okay, as there is no VN supplied, so we consider that VCC has a full of the outputs lah. But as the VN is supplied in higher voltage, the VCC is as a V out, one of element of V out is reduced because of this transistor and resistor elements. Okay, so the relationship between the collector currents, okay, the collector current here, okay, IC, and the base current below saturation is defined as this equation lah. IC is equal to HFE multiplied by IB. So this is the what we call it current gains. Okay. Okay, this is a further discussion on how the relationship between the V in and V out lah. Okay, as there's no V in inputs, so we consider V out is about a VCC. But as a increase voltage is applied, so as a RC is playing roles, that is towards a zero position. So similar to what is explained to this graph. Okay. Okay, so based on the equation previously here, okay, we can have at saturations. Okay, this is below saturation, but at the saturation we have another equation which is IC saturations. Okay, this is IC, which is without saturation. If the saturation, we have IC saturation is a VCC minus by VCE saturation multiplied by RC, divided by RC. Okay, so to ensure that a transistor is driven into saturation, the base current must rise at certain level lah. Okay, so this is another equation which IB saturation equal to IC saturation divided by HFE. So for example, you have a VCC of 5 volts, okay, minus by VCE F1 volts, okay, and given the RC of 10 ohms here, so you can get the value of IC saturations, okay. And based on the IC saturation, if you have the HFE previously, so that you can get the IB saturation value lah. Okay. For this case, if you have all this value, the base current must rise is at least 8 milliamp, okay, to make the circuits works, okay. So that's the principles lah, okay, on the at the saturation level. Okay, so since the IB needs to drive a bipolar power uh, transistor is large, okay, sometimes to move the motor, for example, you need a large currents. So a second transistor is often needed to enable switching to be obtained with a relatively small current. Okay, for example, it's supplied by a microprocessor. Okay, so of course, in general, you have a protective diode here, okay, as a protective elements to avoid the negative voltage, and you have a transistor, okay, and you have another second transistor lah. So we call a term of Darlington pair, where we have mount two type of transistor, which is small NPN with a large NPN, and also a small PNP with a large NPN. This is the basically the combination of what we call a Darling pair as a second transistor, uh, which is to play with a voltage differences, okay, on how you can increase the voltage to a certain level, okay, to make your motor, for example, to move, okay. Okay, so there's another element also, okay, component that been bound to the circuits, what we call it as a buffer, okay. Buffer used in transistor switching to control a DC motor lah. This is example DC motor, you want to operate it, okay, you use a buffer. So what is the function? Is used to increase or invert the drive current to a certain value, okay. If you need to control your drive current to a certain value, or you need it to invert it, you need a buffer basically, okay. So from the base current, the buffer can control the output to the microprocessor. So this is type of buffer when you have a 240, 241, 244 buffer. So there is a each buffer has a their specific function, okay, based on this number. So we can have a looks on what is the function of each of buffers later on. Okay. Okay, the last part is on the MOSFETs, okay. Is called as a metal oxide field effect transistor. Is mostly similar to this bipolar transistor, NPN and PNP, but we have some advantages lah on these MOSFETs as follows. Okay, so so this is the symbol, okay. When the MOSFET is turned on, the current flows from the source to the drain. Okay, similar to the bipolar transistor NPN and PNP, we have also N channel and P channel, where this one is from the source, okay, uh, to the drains, okay, and this is from the drain to the source, okay. And voltage is supplied between this gate source to turn on the MOSFETs, okay. As a general, the gate is controlling the voltage, okay. MOSFET can be turned off by removing the gate voltage here. If you remove the gate voltage, it can be just turned off lah. The gate also has a full control over the overall MOSFET lah, okay. And also we need a level shifter buffer, okay, to raise the voltage level at which MOSFET start to activate. Okay, basically we have a level shifter, such the same as a buffer here in a typical bipolar transistor. So of course it will control the level of voltage. Okay, the similar one of this buffer to increase or invert the voltage at certain value. Okay, so interfacing of this microprocessor, MUP, is basically simpler than transistor lah. Okay, so the MOSFET has the advantage of it have a simpler interfacing compared to the basic bipolar transistor. So the high voltage switching can be up to 1 megahertz, okay, which is this is one of advantage of MOSFET. It can go through a very high frequency operation. Okay, okay, so that's all for today class. Okay, thank you very much.